Welcome to this lesson on combined phase change reactions. In this video, we're going to identify when to use the combination method to determine the energy lost or gained when we take a substance from one temperature to another temperature. And then we'll also list the steps, tips, and some strategies to help you in solving these combo problems. So let's start by looking at an example. Example number 1 asks, how much energy is required to raise the temperature of 30 grams of water from negative 15 degrees Celsius to 40 degrees Celsius? Well, previously, when we were asked this sort of question, we've just been using Q equals MCAT, which we certainly can as long as there is a temperature change and a consistent temperature change. If a phase change occurs between our two temperatures, then we can no longer simply rely on Q equals MCAT because, as we know, during a phase change, there is no temperature change. So now our first step needs to be to determine if a phase change or phase changes are going to occur within the problem that we are asked to solve. And to do that, we need to determine what phase our substance is in when we begin and what phase our substance will be in when we end. So for this problem at negative 15 degrees Celsius, we know that water is in the solid phase. And at 40 degrees Celsius, we know that water will be in the liquid phase. So this question does indeed have a phase change, so we can't just rely on Q equals MCAT. So the next step I recommend is to draw a heating or cooling curve that outlines the different phases and energy changes that the substance is going to go through so that we clearly know how many steps are required in what different pieces we're going to need to solve this problem, whether we're using Q equals MCAT or our molar heats. So for this question, the heating curve in this case, since we're adding energy, would look like this. So we clearly have 3 different pieces to this question. So the first one, from negative 15 to 0, I do have a temperature change. So I can use Q equals MCAT here. And for my third piece here, between my 0 and 40, I also clearly have another temperature change. So I can use Q here as well. However, for this piece in between, this sort of flat piece at 0 degrees Celsius, I have a phase change. My water is going from a solid to a liquid, and I have no temperature change. So I have to use my delta H, my molar heat. In this case, it's going to be my molar heat of fusion, since I'm going from a solid to a liquid. So let's start with our first piece, our yellow Q, while we're in the solid phase. So it's still going to be Q equals MCAT, and I'm solving for Q, and my mass is 30 grams. My specific heat of water, however, is different depending on the phase that I am in. So if I look over here, I can see that in the solid phase, my specific heat of water is going to be 2.108. So I can plug that in, and my delta T, be careful, my delta T is only the temperature change for this particular piece. And remember, it's always final minus initial. So my final temperature for this phase is 0, and my initial temperature is negative 15. So it's 0 minus minus 15. So my delta T is actually going to be a positive 15. So when I multiply these together, I get 948.6 joules, and it has to be in joules because my specific heat was in joules. Now let's do our other Q piece while we're still doing Q equals MCAT. So for this one, we're still solving for Q. Our mass is still 30 grams, but remember, I have to go back and check our specific heat for the particular phase that we are in. And our specific heat in the liquid phase, because I'm between 0 and 40, I haven't yet boiled. So the specific heat for my liquid phase is 4.18. And my delta T, again, is final minus initial, but just for this piece. My final temperature is 40, and my initial temperature was 0. So my temperature change is going to be 40 here. And when I multiply all those together, I get 5,016 joules. And again, it has to be joules because my specific heat is in joules. And now for our final piece, our piece at 0 degrees Celsius, where we have a phase change and no temperature change, we have to use our delta heat of fusion, our delta H fuss. And our delta H fuss, our delta heat of fusion, or our molar heat of fusion is a given. And for water, it's equal to 6.01 kilojoules per mole. So that's how much energy is required to melt a single mole of water. But I don't have a single mole. I don't know if I do. I have 30 grams. So the first step in using this conversion factor is to convert from grams to moles. So when I do my conversion using my molar mass, I find that I have 1.67 moles. So now I can just use my delta H of fusion conversion factor to figure out how many kilojoules are required to melt that much water. So when I use my delta H fuss as a conversion factor, I find that it requires that our 1.67 moles of water requires 10.04 kilojoules to go from a solid to a liquid. So our very last step is to add up the energy calculated from all three of our pieces to find the total amount of energy required to raise the temperature of 30 grams of water from negative 15 degrees Celsius to 40 degrees Celsius. But before we can do that, there's one final step. If you notice, our Q values are in joules, while our delta H fusion, our molar heat of fusion value, is in kilojoules. So we have to convert them either all to joules or all to kilojoules before we can add them up. And I recommend converting them all to kilojoules, as that will make your numbers a bit more manageable and a bit smaller. So when I add up all of my pieces, my first Q value, which I converted from joules to kilojoules, 0.9486 kilojoules, plus my delta H fusion from my second piece, which is already in kilojoules, so I don't need to convert, at 10.04 kilojoules. And then my final piece, which I converted to kilojoules as 0.5016 kilojoules, I get a total of 11.5 kilojoules is required or absorbed by 30 grams of water to raise the temperature from negative 15 degrees Celsius to 40 degrees Celsius. So here are a few steps to help you with your combined phase change reactions. For step number 1, always determine the starting and ending phase of the substance to determine if it is indeed a combination problem, or if you can just use Q equals MCAT as long as there's a temperature change the entire time, or if you can just use your molar heat conversion factor if it's just during a phase change, or if you have to use a combination of both for something that includes both temperature changes and phase changes. For step number 2, I highly recommend drawing a heating or cooling curve to help map out your steps. For step 3, once you've mapped out your steps, you're going to use your Q equals MCAT, where there is a temperature change. But remember, be mindful of the temperature change so that you're only dealing with the temperature change for the specific piece you're using, and your temperature change is always final minus initial, and the specific heat of the particular phase that you are in if dealing with water, because water has a different specific heat for each of its phases, solid, liquid, and gas. For step 4, identify and use the appropriate delta H, either your fusion, vaporization, solid, or condensation, depending on the phase change occurring. Then convert all of your answers to joules or kilojoules so that for number 6, you can add all your answers together to find the Q total. And remember that the value needs to be positive if the process is endothermic and negative if the process is exothermic. And there you have it, how to do combined phase change reactions. Bring any questions you have with you to class.